All right, number 10 asks us to find an equation for the inverse of this quadratic equation. And it says for x is greater than 0.
Please release all of our speaking cell phones. Thank you.
The only problem is it asks us to identify the domain and range of the inverse function. If it wouldn't be for that, this problem would be super easy. But let's start with what we know, and that is to switch up the x's and the y's. So I'm just going to recopy our equation, and we have wherever there's an x, I'm going to put a y, and wherever there's a y, I'm going to put an x. So now I have 7y squared plus 21. Solve for y. That's always what we do when we're writing inverse functions, which means I'm going to bring the 21 over. So that leaves me with x minus 21 equals 7y squared. Divide everything by 7. Remember, I'm looking to get y by itself. So now I have 1 7x minus 3 equals y squared. Now I have to take the square root of both sides, right? So, and I'm going to rewrite this in the kind of more normal order. I have y equals 1 7th x minus 3, and it's the square root of that. So there's my inverse function. Now the problem is I have to identify the domain and the range of the inverse functions. Okay, so the question we need to ask ourselves is what values of x are going to give us a negative value under the radical? So look right here and ask yourself, okay, let's just start with something easy. Plug in a 7 into x. When you take 1 7th times 7, you get negative 1. I'm sorry, you get 1. Then if you take 1 minus 3, that gives you negative 2. That's a negative under the radical, which means that we cannot use 7. What we're looking for is what number here will give us 0. So I'm just going to temporarily set 1 7th x minus 3 equal to 0, because we have to have under the radical, the smallest number that we can have under the radical is 0. So let's figure out where that's going to happen. So we have plus 3, so then we get 1 7th x equals 3. Multiply this times 7 to get x by itself. We multiply this times 7. That's x equals 21. So now come back over here and look at this x. If you plug x in here, 1 7th of 21 is equal to 3. 3 minus 3 is 0. Can you find the square root of 0? Well, the square root of 0 is going to be 0, I guess. But the idea is that it's going to be anything greater than or equal to 21. All right, that's our domain, right? That's the numbers that we're allowed to choose for x. Okay, so the domain is x is greater than or equal to 21. All right, now what are the y values going to be? And to know this one, we haven't talked a lot about this, but to know this one, you have to kind of know something about square root functions. The square root function, generally, the parent function of the square root function looks like this, okay? Never anything down here below the x-axis. So for that reason, we can say that the range is going to be y is greater than or equal to 0. Now, you might also have recognized that just from knowing that the smallest value of x is going to be 21. If you plug a 21 in here, you're going to get 0 for y. And then if you go higher, use higher numbers than that, obviously always you're going to be getting higher numbers than 0 for y. So that'd be another way to think it through if you didn't know anything about the square root function and the way that it looks on the graph. I hope that's helpful.